Hello friends, Rahul Jha welcomes you. Today we will talk on topic what will happen if one third land of earth is covered with solar panel for energy. So let's start. Covering one third of earth's land with solar panels would have significant and wide-ranging effects on environment, ecosystem and human activities. Here are some potential consequences. Energy generation, increased energy production. The primary goal of covering such a large area with solar panels would be to generate a massive amount of renewable energy. This could significantly contribute to addressing global energy needs and reducing reliance on fossil fuels. Environmental impact, land use change. The conversion of natural landscapes for solar farms would result in the displacement of ecosystems, habitats, and biodiversity. This could lead to loss of biodiversity and disrupt local ecosystems. Alternate microclimates. The large scale deployment of solar panels can influence local microclimates. For example, solar panels absorb sunlight and can create a warmer environment underneath, potentially affecting the temperature and moisture level of the soil. Water usage, water requirements. Solar panels often require water for cleaning and cooling purposes. The increased demand for water in these regions could strain local water resources and impact aquatic ecosystems. Agriculture and food production. Impact on agriculture. The conversion of agricultural land to solar farms would reduce the available land for food production. This could potentially lead to food shortages and impact global food security. Human displacement, population displacement. The installation of solar panels on such a large scale would likely require displacing human population from their homes and communities. This could lead to social and economic challenges, technological challenges, maintenance and upkeep. Managing and maintaining such an extensive solar infrastructure would pose logistical challenges. Dust, debris, and weather conditions would require ongoing efforts to keep the solar panels functioning optimally. Economic and social implications. Job creation. The deployment of solar panels would create jobs in manufacturing, installation, and maintenance. However, it could also lead to job losses in industries affected by land use changes. Global energy security. Diversification of energy resources. The widespread use of solar energy could contribute to global energy security by diversifying the sources of energy and reducing dependence on finite fossil fuel resources. It is important to note that such a scenario would have complex and interconnected effects, and careful planning and consideration of environmental, social, and economic factors would be necessary to mitigate negative impacts. Additionally, technological advancement and improvements in energy storage and transmission would be crucial to make such a large scale solar deployment feasible and efficient. What if we covered the earth with solar panels? Covering the entire earth with solar panels is a hypothetical scenario that poses significant challenges and consequences. While it may sound like a solution to global energy needs, it is important to consider the practical and environmental and social implications. Logistical challenges. Manufacturing and installation. Producing and installing a sufficient number of solar panels to cover the entire earth would be an enormous logistical challenge. The scale of such an operation would require vast resource, including materials, labor, and energy. Land use and environmental impact. Loss of ecosystems. Covering the entire earth with solar panels would mean converting natural and landscapes, including forests, deserts, and wetlands, into solar farms. This would result in loss of biodiversity, disruption of ecosystems, and potential extinction of many species. Climate and weather changes. The massive alteration of land cover could have unpredictable effects on local and global climate patterns. Changes in heat absorption, wind patterns, and moisture distribution could have cascading effect on weather systems. Resource limitation. Material resources. The production of vast number of solar panels required would strain global resources, including metal, minerals, and rare elements used in panel manufacturing. This could lead to resource depletion and environmental degradation in the mining areas. Energy and water use. The manufacturing, installation, and maintenance of such a massive solar infrastructure would require significant amount of energy and water, contributing to environmental stress, social and environment economic disruption. Human displacement. Covering the earth with solar panels would necessitate displacing entire population from their homes and communities. This will lead to social upheaval, economic challenges, and potentially conflicts over land use. Global inequality. The implementation of such a project could exacerbate global inequality as certain regions might bear the brunt of environmental and social impacts while other benefits disproportionately. Technological and infrastructure challenges. Maintenance and upkeep. Maintaining and managing such an extensive solar infrastructure on a global scale would pose unprecedented challenges, technological failures, weather events, and other unforeseen issues would require constant attention. Transmission and storage. Transmitting and storing the enormous amount of energy generated globally would require advanced and efficient technologies that are not currently available. Aesthetic and cultural concerns. Aesthetic impact. The visual impact of covering the entire Earth with solar panels would alter the planet's appearance drastically. Some people may find this change undesirable, impacting cultural and aesthetic values. While the idea of covering the Earth with solar panels highlights the potential of renewable energy, the practical challenges and environmental consequences make it unrealistic and unsustainable proportion. Instead, a more balanced and thoughtful approach incorporating a mix of renewable energy source, energy efficiency measures, and conservation efforts is crucial for addressing global energy needs while minimizing negative impacts on the environment and society. What if whole world runs on solar energy? Transition Transitioning the entire world to run on solar energy would have several positive and transformative effects, but it would also present challenges that need to be addressed. Here are some potential outcomes. Advantages: renewable and sustainable. Solar energy is a renewable resource, meaning it is inexhaustible as long as sun exists. This contrasts with finite fossil fuels, contributing to long term sustainability. Reduced greenhouse gas emissions. Solar power is a clean energy source that produces little to no greenhouse gas emissions during electricity generation. Transitioning to solar energy on the global scale would significantly reduce the carbon footprints and mitigate climate change. Energy independence. Nations would become less dependent on fossil fuel imports, leading to greater energy security and reducing geopolitical tensions related to energy resources. Job creation and economic growth. The solar industry would create jobs in manufacturing, installation, maintenance, and research and development. This could stimulate economic growth and provide new employment opportunities. Decreased air and water pollution. Solar energy generation produces minimal air and water pollution compared to fossil fuels, contributing to cleaner air and water quality. Decentralized energy production. Solar panels can be installed on rooftops, in remote areas, and even on small scales, promoting decentralized energy production. This reduces the need for large centralized power plants and associated transmission losses. Improved energy access. Solar power can provide electricity to remote and off grid areas, helping to bridge the energy access gap and improving the quality of life for those without reliable power source. Challenges and consideration. Intermittency and energy storage. Solar energy production is intermittent and depends on sunlight, which varies by location and the time of day. Effective energy storage solutions, such as advanced batteries, would be essential to ensure a stable and reliable power supply. Land use and environmental impact. Large scale solar installation would require significant land area, potentially leading to habitat disruption, ecosystem changes, and conflict over land use. Technology and infrastructure. The global adoption of solar energy would necessitate massive investment in solar technologies, infrastructure, and energy storage systems. Advances in technology would be required to make solar energy more efficient and cost effective. Transition challenges. Transitioning from existing energy system to a solar based system would be a complex process. Challenges include retrofitting existing infrastructure, overcoming political and economic barriers, and managing workforce transitions in traditional energy sectors, resource availability and supply chain issues. The production of solar panels requires specific materials such as rare earth elements and metals. Ensuring a stable supply chain and addressing potential resources constraint would be critical. Energy equity. Ensuring equitable access to solar energy and avoiding socio-economic disparity in its benefit would be important. Without careful planning, the transition could inadvertently exacerbate existing inequalities. In summary, transition transitioning the entire world to run on solar energy offers numerous environmental, economic, and social benefits. However, addressing the associated challenges and implementation, comprehensive and thoughtful policies are essential to ensure a successful and sustainable global energy transition. What will be effect on climate? Transitioning the entire world to run on solar energy would have both direct and indirect effects on climate. Here are some potential impacts. Reduction in greenhouse gas emissions. The primary direct impact would be a significant reduction in greenhouse gas emissions. Solar energy generation produces little to no carbon dioxide during operation, unlike fossil fuel-based power plants. This decrease in emissions would contribute to mitigate climate changes by reducing the concentration of greenhouse gases in the atmosphere. Climate stabilization. By shifting away from fossil fuel to solar energy, which is a clean and renewable source, there would be a positive impact on climate stabilization. Solar power does not contribute to release of pollutants and greenhouse gases that leads to global warming and climate variability. Decrease in air pollution. The reduction in the use of fossil fuel for electricity generation would lead to improved air quality. The decrease in air pollution, including particulate matter and pollutants like sulfur dioxide and nitrogen oxide, would have positive health effect and contribute to climate mitigation. Positive feedback loop. As the world transitions to solar energy and reduces reliance on fossil fuel, the positive environmental impacts can create a feedback loop. Lower emissions can lead to reduced global warming, which in turn can further enhance the viability and efficiency of solar energy systems. Altered land use and local climate effects. The large-scale deployment of solar panels may have localized effects on land use and microclimates. Solar panels can influence the absorption and reflection of sunlight, potentially leading to changes in temperature and moisture levels in the area where they are installed. Energy efficiency and conservation. The global adoption of solar energy may encourage greater energy efficiency and conservation practices. The focus on renewable energy often goes hand in hand with efforts to reduce overall energy consumption, leading to a more sustainable approach to resource use. It is important to note that while the direct impact of widespread solar energy adoption is positive for climate, the overall effectiveness in mitigating climate change would depend on various factors, including the speed of transition, the integration of energy storage solution to address intermittency, and success of parallel efforts to reduce emission in other sectors such as transportation and industry. Additionally, the manufacturing and disposal of solar panels involve certain environmental impacts, and careful consideration of the life cycle of solar technologies is essential to ensure truly sustainable and climate-friendly energy transitions. Overall, the transition to solar energy is a critical component of broader strategy to address climate change and move towards a more sustainable and low-carbon future. Thank you.